Welcome, everyone.
Hey.
So, a bit of a different setting today, a bit of a different crowd today. So, for those of you who don't know who these guys are, I mean, you would be able to tell by the brand.
I'm Josh, and
I'm Sanjay.
Yeah. So, yeah, today we're just going to do a bit of a casual Q&A, unscripted, nothing really in particular planned. But so if you have any questions, of course, only if you're watching this live. If you're watching the recording, then it's too late. Sorry. But if you have any questions live, go ahead, ask them in the live stream. I will have. Oh, Nightbot is here. Cool. I will have an eye on that. So ask there, or if you want to have questions, we still have the backup feeds on Twitter. All right. So. Yeah, let's start with that one right.
Oh, you
there.
want to start with this straight away?
Start with that.
water cooling.
Yeah. Okay. Got cables trailing.
Yeah, we had a power supply plugged into this at the TCT show. I don't know who made it to the TCT show, but we were showing this off.
Thank you for anyone that did come. It was awesome seeing everyone. By the way. It's huge.
So yeah, we were showing this off for the first time. Then it's something that's been in the pipeline for a very long time. Anyone that's been frequenting our website over the last 2 years will have seen on the Cyclops page that water cooling been coming soon.
Yeah.
So yeah, it has in fact now arrived.
We have arrived.
Believe it or not.
Is it overkill?
Well, I mean, it depends on your application.
I mean, you've got to think about the objectives, because the reason for using water cooling isn't we need to take more heat out. The reason for using water cooling is that you can transport heat in a more efficient way.
You can quickly remove large amounts of heat.
Exactly.
And you can also keep it at that low temperature if you have enough cooling. You can add more cooling than you could with a tiny
exactly. So for example, there's on something like this where we've got this is the Titan Aqua. So the entire back plate is water cooled, which means that it's not only water cooling the cold side of the hot end, but it's also water cooling the motor behind it. So that's obviously an advantage if you want to be running a smaller motor at higher currents, so that you're getting more heat.
And so people always ask me why, and the simple answer is heated chambers. If you have a heated chamber and you have an air-cooled hot end, you're not going to be able to cool your hot end because the air is hot. Water cooling is amazing because it allows you to transport heat out of the chamber. So you can have the heat sink, or what do you call it, a radiator, I suppose, on the outside, and then you have the thing that you want to cool on the inside. And so, shall we maybe start with this one?
Yeah, for sure.
Yeah. So what we've got here is a water-cooled Chimera. But basically, now that we're into like the modular ecosystem, what this is a water-cooled heatsink for 2 heat breaks, which means that we can either put in Cyclops if you're feeling crazy, or you can have just 1 or 2 V6 style tool heads.
Yeah, which is Chimera style, so how it used to be.
Yeah, so this one on the left, this does have 2 filament inputs right now.
Yeah, exactly.
Single block, so they combined it. It's not mixing it, but it's at least 2 in 1, and you can switch. How is weight on that versus the traditional air-cooled stuff?
So the weight on the on the Cyclops cooler block, or actually, have we got a name for that yet?
We should
come up with a name.
I think that it's being called the Trident system because there are 3 configurations.
Oh, I guess there's the Trident system is the water cooling part.
Yeah, and this is Titan Aqua to contrast with Titan Aero.
Exactly, but we're not entirely sure if there's a name for the Cyclops water cooled sink. So perhaps suggestions welcome in the.
Please do.
Yeah, suggestions welcome in the live chat. But yeah, basically it's a slightly different design from Cyclops old style. So actually Cyclops Plus is a millimeter more widely separated.
2 whole millimeters.
2 millimeters. Now the reason for that is to make sure that on the Chimera configurations you can get both of the heated blocks in with socks on. So that's kind of a small improvement, so that it makes it totally modular. So you can run Cyclops, 1 heater block or 2 heater blocks, and that's all consolidated on a single heatsink.
If you're feeling super crazy, kind of accidentally by increasing the...
No, that was intentional.
Yeah, so it's somewhat intentional, but like what it means now is that if you're feeling nutty, you can put 2 Cyclopses into a Kraken. Get that straight, 2 Cyclopses into a Kraken and have 4 inputs, 2 nozzles, and print lots of colours.
Yeah, it's a bit crazy.
Makes me,
While we're on about Kraken, this whole system is kind of designed as a bit of a improvement to the whole Kraken system as well. So we used to just provide a tiny little pump, and I don't know, I'm sure there are people out there that had lots of beautiful cooling systems, but for us normally worked out as a little pump sat inside a Tupperware with some holes drilled in the top and some zip ties. It wasn't particularly glamorous. I mean, it always worked fine. We used a radiator where necessary, but the whole setup wasn't particularly neat, so the Trident water cooling system obviously is kind of a neat solution to all of that.
Yeah, and just for clarity, we'll be selling the water cooling separate to the hot end, because we know a lot of people who are running heated chambers already have water cooling setups, or they might want to reuse like whatever crazy water cooling setup they want. So the water cooling setup, this kind of set of radiator, fan, reservoir and pump, is a product that you can buy and use on either a Kraken, a Chimera, Titan Aqua, Aero, whatever. All E3D water cooled products will work with this system, and then you buy whichever hot end you like.
Yeah. Hoopship is asking price.
That is a good question.
That's sort of undecided at the moment. So a lot of this, the water cooling stuff, I mean, it's really to support the kind of other stuff that we sell. So we're looking to kind of make that as affordable as possible, basically because it's designed to work with, as we were saying, the Titan Aqua, Cyclops stuff, and the Kraken.
All right. So nothing in particular is set yet.
Yeah, no, nothing's been decided.
I mean, to
yet.
give you like orders, the Cyclops heatsink is no more complex for us to make really than the standard one. So this shouldn't be much more than the standard one, but you will have to buy a water cooling system. And I don't know exactly how much that'll be, but it'll be less than £100. I'm quite sure.
Definitely.
Can we get a closer look? Just scoot it into the camera.
Yeah, sure.
Let's move it closer. People want to see all the gritty details.
So
there we go.
Is it alright if I get in front and point a couple of things out just quickly?
I think we don't need to go that much into details. Yeah.
I love details.
All right.
So actually, what you're seeing there is two separate
it's two
rings.
sets.
So it's actually divided here. So we're just displaying that it can be used. You don't need two pumps. You don't need two radiators. But yeah.
All right. Definitely, a lot of people are actually suggesting Poseidon as a name for the system.
Yeah.
Yes.
Makes sense.
Yeah.
All right. Question from where was it? Someone. Sorry if I'm not mentioning your name. So this is for enclosed chambers. So you're adding more heating.
That's one of the applications. Certainly. Yeah.
But can you run the traditional V6 without any active cooling in in an open chamber?
No.
No. Okay.
Traditional V6 without any active cooling in an open chamber.
Yeah.
A traditional V6 needs active cooling in all situations.
Oh, sorry, but okay, active meaning like just like
without the fan.
Okay, yeah, no, you always.
No. Okay. Even for ABS.
Yes.
Edge case, I guess. Yeah.
There are some edge cases where you might be able to get away with it, not recommended or guaranteed or supported.
Yeah. One of the things which we can, I suppose, share on this slightly kind of more informal chat was about the Light 6 kind of development process.
Yeah, so actually that's been the Light 6 with the Teflon liner versus traditional V6 all metal. That's actually been a topic that's been requested quite a few times.
Okay,
why are you so keen on all metal?
So right. I'm gonna let you in on our little secret about Light 6 first, which was that originally we actually were trying to design it in such a way that it didn't require any active cooling, so that it could be totally passive. That was one of the reasons for having the Teflon liner and the stainless steel heatsink, to reduce the amount of thermal conduction up there.
We got really close.
Like in a lot of cases, you can actually get away with the Light 6 without any active cooling. I mean, it's not a recommended configuration.
It's kind of like the older peak-based hogs, right? With the Teflon liner, you take out a lot of the variables.
Yeah, like a J-head would, it would run most of the time, but they're a lot better off when you actively cool them.
So, I mean, if that's something that was kind of a requirement for one reason or another, that's something that you could try. But how well it would work, we can't really guarantee, because obviously now we decided, okay, it does actually need active cooling, hence that's why it comes with a fan.
And there are so many environmental variables that we can't control as a manufacturer.
When it was cold in the workshop, it worked fine. When it was really warm, less well. So.
Okay, but what would be the reasoning to stick with an all-metal hot end in the first place?
Temperature.
Yeah, temperature, broadly.
But why? When you're printing PLA or PTG, do you really need it? Does it make a difference?
So, still, when people are just printing PLA or ABS, you would still get these situations where your temperature would run over and your hot end would pop out and fail miserably. So metal hot ends are just generally more robust and forgiving. Additionally, what people often don't get is that the sharp thermal transition of an all-metal hot end, while it is necessary for reliability, also increases performance, because the force, like the transfer function of inserting filament.
It's more direct.
Yeah,
right?
It's more responsive. It's more responsive to extrusion, so you get more accurate extrusion, cleaner retracts, better starts and stops.
Yeah, and I think also really importantly, you don't have that transition moving. So if you're going really fast, there's the risk that if that kind of transition zone wasn't tightly controlled, that the transition zone would move down. And so obviously enough, when that moves down, you've got a larger area of the hot end that's got 175mm material in it, and a smaller section that has the swollen 2mm material in it. So that the difference there actually changes. So over time in the dynamic system, you can have a kind of hysteresis. So you add material and you get more out initially, and then it slows down later. So controlling that really tightly means that you get a much closer relationship to what filament you put in and what extrudate you get out the other end.
Yeah, because I suppose a misconception is that it's always one-to-one. In the long term it will be one-to-one, but in the short term it's not.
Exactly. On the topic of getting the all-metal hot ends reliable, is it a good idea to add oil to the filament path, or to what's called to prepare the heat break with some canola oil? You know, those tricks that are around. Or would you advise?
It shouldn't really be necessary. I'm not going to advise against it. A lot of people have great results with it, right?
They do it, and it works for them.
Our philosophy is that shouldn't be necessary, and if you are having a problem that you can't solve, then get in touch with us, because maybe that's something we need to look into and do better on. But we have not oiled heat breaks and never had problems, so we can't reproduce these issues a lot of the time. It's probably
edge cases.
Exactly.
But I mean, those exist.
Yeah, and when we're talking about edge cases, we're talking about the direct extruder with no gearing reduction, maybe a kind of weakish hot bolt or badly tuned stepper motor current that you often get on these cheap printers. Maybe add in a Bowden system to add extra drag and hysteresis, and then you've got a really marginal system.
Or perhaps some filament that behaves slightly differently in the melt. I mean, it is something that we've seen, and like Sanjay says, obviously there have been improvements that our customers have seen, and you know, we've tried it and not seen any negative effects. So it is something that can be tried and played with. But yeah, we'd kind of be really interested to hear the test parameters that people are seeing in order to kind of need to do that to their heat breaks.
Yeah. Go watch the CNC Kitchen video on oiling filament. It's super cool. I love that guy's channel.
Yeah, absolutely. Whipship is asking, when having a very sharp transition, don't you have problems more often with molten filament creeping up the sleeve neck and hardening, causing a jam?
So if you we cut open a lot of hot ends. So we have this trick that we do where if we want to investigate something, we kind of reproduce it and then dunk the hot end into cold water to try and get a snapshot of what it is and mill it in half. Or you can do things like cold pulls and stuff. And what you find is that the material goes down and it expands under pressure, and it's not a liquid here, so it's not like water and ice where it turns from one to one. There's a transition, and what that means is that this part forms a seal. It's almost like an O-ring in a hydraulic system. And that O-ring is actually being sealed by the force of the compression here, expanding it outwards. And so you've got this seal pushing it down, and material, it doesn't flow back upwards.
So as soon as it gets to the cold areas of the heat break, it hardens and it forms that seal, right? And that is much sharper and much more controllable in that all-metal sharp transition.
Exactly. So you've got this plug flow section, and that is the seal.
The key is that it's not molten there, I think. That's the...
Yeah.
Chase Vichert is saying he misses the big box.
I know, we all miss the big box. Yeah, I mean, we put out a blog post about that a few months ago now.
You did what was best for it.
Yeah, I mean, it's a wonderful printer. We still have a whole print farm. We have like 25 printers sitting downstairs. Greg has, I think, 5 or 6 next door, all in weird and wonderful incarnations to test lots of crazy projects of ours. We still use it as a workhorse, like here.
Yeah, you still have like 30 or 40 of them just around.
Yeah, there's 25 downstairs, and there's another 10 probably floating around the workshop. We use it all the time. I mean, we kind of went into the details as to why we decided to make the call to stop selling them in our blog post. But essentially the market was changing. It was very much aimed as an enthusiast printer, something that you could rip apart, you could work on, you could hack with, and we kind of weren't set up for it in the current building and the space that we have available to us. So it was a sad decision, but yeah, we miss it too.
All right, Lou Jans is asking, what is the big difference with the normal heat break and the new titanium heat break?
Yeah.
Why?
Yeah.
Why? Can we move this out of the way?
Yeah, sure.
So originally...
Quick question, if you're wondering about that, just jump back like 10 minutes, we were talking all about that.
Yeah. Titanium heat breaks were originally developed for a specific customer that had marginal cooling.
Do we have some here?
They look exactly like
you can't tell the difference.
We can't tell the difference. We have to keep them in a box
separate
upstairs
box, and log when people take them out. So they were made for a specific customer because titanium has an even lower thermal conductivity than stainless steel. The reason why we don't use titanium for everything is it's hard to machine and it's expensive. But this customer, they were getting a bit of heat creep and they couldn't get their fan going quite as much for lots of reasons. And so using a titanium heat break cuts about in half the amount of wattage that goes upwards.
That's conducted
Yeah,
upwards.
that's conducted through the heat break. However, really, our main reason for releasing them is that they're stiffer and they're stronger. And so we have a lot of customers, especially industrial ones, that are using Volcano. And if you have a printhead crash with Volcano, it's got a longer lever and it will quite happily bend the heat break if you have an aggressive crash, especially on these heavily built industrial machines. And so the titanium heat break gives you a lot of extra stiffness and toughness up there, or resistance to being permanently bent.
Yeah. So I mean, even though that's kind of a marginal case, if people do encounter that, it does reduce the risk of permanently damaging a heat break. So even though they are like 3 times the price of a normal heat break or something,
but they're basically going to last forever.
Yeah, exactly.
And we find our industrial customers, they don't really worry about the price. They need the product to be reliable.
Yeah.
And the reason why they're so expensive, guys, is because titanium is an absolute pig to machine. It is not fun at all.
Yeah, we are looking at trying to get that down. But yeah, it is a challenging material.
All right. Quite a few people are asking about your point on the E3D clones. How does E3D like the E3D clones?
Yeah, well, I mean, designing a hot end is one thing, and having the design, being able to make it and quality control check it. And Tom's taken a lot of video and will probably show you what the efforts that we go to go through quality control. But a hot end is entirely predicated on fantastic manufacturing, and if you don't have fantastic manufacturing, the hot ends don't work. It's really that simple, right? There's not much to it. And the clones, they are to the same vague dimensions, but they don't work, and that's because they're not manufactured to the same standard that we do.
Okay,
Yeah,
well, that's
the other aspect, of course.
I mean, you guys are E3D, so
Yeah.
I wouldn't expect you going like, they're just as good, buy them instead. But are they affecting you as a business, as a manufacturer? Are they slowing down development, or
We don't see.
How?
Yeah, no, we don't see people kind of running to clones all the time. I mean, our pricing isn't crazily higher than what the clones are able to produce. We offer the customer service that obviously a lot of the clones don't offer and can't offer those kind of other companies. But yeah, I mean, people seem to recognise the kind of the brand and the product and the quality, and don't tend to run away to the clones. I mean, you see a lot of horror stories on the internet, and I think it does put a lot of people off, and they think, you know what, I just want this to work first time. I can't be bothered, messing around with that. So
Yeah.
in answer to your question, simply, I mean, not hugely.
all right?
Yeah.
Cool. And I guess it is establishing the E3D V6 form factor as kind of a standard in
Yeah.
the
Yeah,
entire
great.
market.
In many ways, and people are doing crazy cool things. Like René Girac is doing, he's made that crazy cool water-cooled heatsink, and he's done his own heater block, and it's designed around an E3D heat break because he buys those in. And also his cool nozzle stuff. They're like the airbrush nozzles, which blow my mind. But like that is really, really cool to see that. Yes, we have some sort of a standard guideline that allows people to make cool stuff, and you see people like MicroSwiss making innovations and improvements, and that's cool as well.
Yeah. Cool. Maker Parts and a few others are asking when will the V6 hot end be released, and what would that look like? Someone asked, are you changing, or are you ever planning on changing the form factor of heat sinks? So what's next? If you can share that.
we can't put a date on it quite yet because things are under active development. But there will likely be quite a change in the form factor of the the hot end extruder system for us, and I think that's probably as much as we want to say at the moment.
Yeah, I will maybe say that we learned a lot about hot ends when we launched and sold V6, and then we learned a lot about extruders when we launched and sold Titan, and then we learned a lot about extruders and hot ends together when we mashed those two together to make Aero. But Aero inherited a great deal of technical debt from either one in order to be compatible. So I would say take that to its logical conclusions and be excited.
Yeah.
All right. To catch up on chat, Trig99 is saying E3D hot ends turn shit printers into gold.
We see a lot of people doing that.
Yeah.
People will go online to kind of Aliexpress or whatever, buy a $200, $300 machine. They don't even try and print with it. They'll take the hot end out, they'll take the extruder out, they'll replace it with Titan Aero or like a V6 and a Titan, and be really happy with the performance of the machine.
Yeah.
So it's an interesting paradigm.
Yeah. Stephen Lookett is saying, what about Triangle Lab on Aliexpress? They sell Titan extruders super cheap. Is that also a clone?
Yeah, those are also a clone. It took them all of 6 weeks, I think.
Yeah.
Or less. That's a clone.
We've bought them.
Yeah, we bought them. I have a couple. Yeah, I mean, again, it comes down to manufacturing, and you look at their hub bolt profile versus ours, and we spend a lot of time in queues because Tom got sketchy about that, that we use the plain bearing shaft of the motor as a pin about which to hinge. And
it looks wild,
but it's great. It works really well.
To me, it works.
I mean, we've got thousands and thousands of hours running.
We've had one failure.
Yeah,
and I must say that's from a guy who filed his flats on his motor shaft,
so
and then
he didn't have the smooth surface anymore.
Exactly.
It up. Okay.
So we spent a lot of time considering, the tolerancing there, and the way that the injection mold is made is designed so that it works very effectively against that part of the motor, and also speccing up the material that we use there. So yeah, like Sanjay was saying earlier, the designs are one thing, but the actual manufacturing techniques and methods when you're doing something so like small like this is
and a lot of the time if you don't know how and why it was designed, there's no way you can figure out how
you can make something that looks like it, but functionally it might not. Sergio Gomez is asking, what is the ultimate V6 right now? Titanium heat break, copper heat plug, and plated copper nozzle?
That's a really interesting question. So
then one more, 3D Iceland is also asking what the copper blocks and nozzle, how they fit in, what the differences are.
Cool. So I'll go through that. Let's start with copper blocks and nozzles.
Right.
So copper has a higher thermal conductivity. It also has a higher thermal mass, and the amount of thermal flux you can put into the plastic is the product of the mass and the thermal mass and the conductivity. And so heating that block up, it may take a little bit longer, but you get way more stable temperatures, and your ability to extrude quickly and then recover and melt more plastic per second is improved by that. So that's why we've chosen copper. And I must also
there's the temperature thing. So for some people that are doing some really crazy stuff, aluminium doesn't cut it. Getting up to approaching 400 degrees, the aluminium begins to soften. Whereas if you want to go higher than that, then copper is kind of your only option, and also has those additional benefits if you're at those temperatures as well.
Yeah, so those blocks are good to 600, which is more than you should ever need.
Yeah. The reason that they're plated is to prevent any of the kind of nasty oxidization that you see with copper at temperature. And
the plastic doesn't stick to it nearly as much.
Engineering, printing.
Alex Gibson is also asking about high temperature printing, especially nylon. What are your best practices with dealing with the intensely hot material?
May I just jump back because we missed a question about what is the ultimate V6? That's really interesting. So I was sitting there, with Greg, and when Greg builds a hot, he's the guy that prints the most here, and when Greg builds a hot end, he doesn't use the standard parts. He goes and he gets a copper heater block, and he gets a hardened steel nozzle, uses a standard brake, uses these fancy heater cartridges that we bought in. They were too expensive for us to roll into mainline production, but they are incredibly good, and so on and so forth. And we're like, the product we're using is not the product that we're shipping to our customers. And so what we're doing is releasing a V6 Gold Edition. Do we actually have one of those kicking around? I'd like to show it off. It's really a gold edition, and it's not just a bling bling hot end.
Well, it is too. But
oh yeah.
So the reason it's gold is for nothing other than that, you know,
bling.
that's a bit bling.
Yeah, for sure. Absolutely, you can't deny that.
Well, I guess you could argue, well, thermal radiation, etc. It might change.
You might be
Find a reason. But yeah, no, it's super cool, and it means that it's because a lot of people just buy a V6 and throw away or not throw away, but put in the toolbox the old nozzle and the old heater block, and then they have to buy the other bits, and that works out to be quite expensive. Whereas if you just buy the gold V6, you're actually a saving versus buying all the parts and putting it all together. So it's cool. It gets people the hot end that we think they might want at an attractive price point for that performance.
Right.
So I mean, again, kind of back to the question: what is the ultimate V6? We haven't actually launched that yet. There was an email that was supposed to go out a couple of days ago about that, but our website. So yeah, that's going to be coming out, I think, in the next few days, basically.
Okay. Sanjay, what are you using for your hair?
Oh,
Stephen looked at once asked.
I have used Dimmerfix in the past.
This is going to turn into a fashion.
There we go.
What is it?
So this is
style.
VO5 texture surf style.
That's boring. I was expecting, like, I don't know, some 3D printing products in there.
I have used Dimmerfix.
I mean, that by itself is a statement. Yeah. All right. A lot of people are asking about the ceramic materials. So ceramic heat breaks, ceramic coated nozzles, parts. What do you think about those?
Something that we've played with in the past.
Yeah.
Also, is that an E3D cup?
Yes. This is an E3D mug. Are we intending on, like, what are we?
We're saying we've got 250. They're going to go on the website.
All right. So you can't buy them right now, but they will be available.
Yeah. Maybe we might put them in as like a freebie when you spend over X. I don't know. We haven't really thought about it. We were just like,
here's a gold V6 heatsink which has been anodized. It's actually not made of gold, but yeah, anodized.
Well, that would be nice. Collector's edition.
Nice and heavy.
Yeah.
And we had the molders run a special run of clear fan ducts, so you're not obstructing that gorgeous gold. You want everyone to see your bling, right?
Yeah, it's still polycarbonate.
Oh yeah, it's still polycarbonate, and then we've actually had them. Normally the fans are PBT, but we're having them throw some fans in polycarbonate, so they're clear as well.
Nice.
So you've got full clear everything.
So yeah, here's the heater block with the sock on it. So this has got one of the new socks with the cutout front for the nozzle. It just looks like a standard aluminium block because obviously it's metal looking.
Coated?
It's
chrome plated or
nickel.
Okay.
Nickel chrome. But yeah, that's copper under there. And then I think this feels like a normal heat break.
Yeah.
You can actually feel the weight difference. So the titanium the titanium brakes weigh like appreciably less than a heat brake. As you obviously add up the entire weight of the hot end, it's a meager difference. But there is.
And you can combine those either way you want. So you've got the stainless steel nozzle, you've got the copper block, and you're screwing in whatever.
Yeah, it's all
heat
the
break.
whole ecosystem.
So it's fully compatible. There's no right.
So yeah, so there's the hot side, and then that screws into the golden heatsink.
And we've got these fancy, nice heater cartridges,
With the green sleeving.
Yeah, sleeving, Molex microfit connector. They're made with a different process that is a bit more accurate, but considerably more time consuming. But they're really
expensive.
But
they're about 3 times the price, I think, than a normal heater cartridge. But
they are glorious. Again, I don't know. We should probably put some pictures up after the stream. But these
just up on Twitter.
Yeah, these cartridges are glorious. I mean, they are absolutely dead round. They've been ground at the end, so yeah, they're really aesthetically pleasing.
Heater cartridge porn.
Yeah. I know. Best keep this as a highbrow stream.
Don't get this demonetized, please. Yeah. Right. So that is your ultimate hot end that you would consider the best you can get right now.
And then we've got this stuff as well, which is about to go up. So this is Bowden tubing it's got an internal lubricant, so it's more lubricious than standard PTFE when filament rides over it. I don't know how they've done that because PTFE is already so slippery. But what's super cool is the inside diameter is toleranced at 1.8 millimeters, which for Bowden systems is huge. It makes the whole responsiveness of the Bowden system drastically better. And so we'll be releasing this as an optional extra upgrade for Bowden systems that we would highly recommend.
Yeah.
Cool.
And that obviously just fits straight into the top of the Gold or any V6. Yeah, and we've actually also got these new little Colic clips, which are kind of very smaller side.
Penny a piece?
I think there's something like that. I mean, I think we ordered 5 kilos of them. That was the absolute minimum.
How many have been?
I mean, unlimited.
Enough.
We have a lot.
Yeah.
But yeah, they're great because they hold the collet up, which means that as you retract and extrude and retract, extrude, retract, that you absolutely guarantee that there is no movement in the PTFE inside the top of the heatsink.
Yeah. PTFE, is this Capricorn PTFE?
Yes, that's the stuff. I was searching for the name in my head, and then I couldn't remember, and I didn't want to try and remember on stream. But yes, you got me, Capricorn. I'm writing a really in-depth technical deep dive blog post at the moment into Bowden systems, the physics thereof, how to improve them and tweaks, and how we might build them in the future. So yeah, watch this space for that blog post, and I'd be really interested in people's feedback.
Right. Quite a few people are asking towards the direction of the Prusa Mark III, and okay, let's go through that. So Volcano on a Prusa i3, good idea, bad idea?
To me, it sounds like a great idea. Now, what I must say is that those guys have spent a lot of time optimizing things down there.
That is for the genuine Prusa i3.
Yeah.
Right.
Yeah, absolutely. For the Prusa i3. i3 Mark III, genuine, original Prusa.
Yeah, Joseph Prusa.
That's the one, yeah. So, for that one, before you mod it, consult their documentation, is what I would say, because their firmware is it performs a lot of error and safety checking, and if it's not heating up in the way it expects it might, which a Volcano might heat up differently, then it's going to throw errors at you. Okay. So check with those guys before modifying their printer. Okay.
Prusa Mark III is using the bigger fan on the on the heatsink. Have you looked into going with a 40mm fan just to save on noise?
Yeah, I mean, basically our opinion on that is that the community has sorted that out really well, and to make a larger fan duct for 40mm, they're all quite machine specific because 40mm is so big.
It's going to get in the way.
Yeah, so which way do you want to mount it? Everyone has different approaches to that depending on your carriage.
Yeah, and this one already you can flip around, right?
Yeah, exactly.
To either offset it to the top or the bottom. That's something that was asked on TCT.
With V6, we're super design constrained by compatibility, and so we like to make things that are compatible as possible, so that more people can use them, even if that does mean the fan's a bit noisy.
Right. I mean, the obvious answer to that is something like water cooling. I mean, obviously that has a price implication, but
it's probably overkill for most.
But it's overkill. It's overkill for most machines, but it does eliminate a lot of the noise because you've got such a big fan.
Yeah.
All right. Cool. Where was I?
And water cooling makes packaging and design really easy because you don't need to account for airflow around, so you can have like these super tight, super tiny like end effector carriages with no fan.
Insulated.
Yeah. All right. Superjet is asking, when will we see an E3D chocolate extruder?
There's something. I can't say, but
yeah, we've been wanting to play around with more funky style extruders for some time. We've been quite kind of bandwidth constrained at E3D over the last kind of year, really.
Yeah.
But there's a couple of things in our pipeline that we're looking at.
Sweet. Why don't you guys have an email mailing list?
Email list?
Newsletter kind of thing?
We do have. If you at the bottom of every page, I think there's a sign up for our newsletter. Okay, so yeah, feel free to sign up. I think that I don't know exactly what happened, but when we transitioned all of our customers from our old site to our new site, I think that some newsletter subscriptions might have got lost. We're not 100% certain. We need to do a bit of a check on that.
You can always resubscribe, I guess.
Yeah, exactly.
And we only send out cool stuff. So
we send out about one email every 3 months. So you might not even think that you're on
decent.
It. Yeah.
All right. Color mixing, multicolor. It's something that comes up like every time.
Yeah.
And
I think we even spoke about it last time you were here when you came and
and you were like, oh, we're reviving the color mixer.
So it has been revived. There are
new iterations.
There are new iterations. Things are happening. We're still facing a couple of a couple of big challenges there.
So what approach are you taking? Are you going something? So I've been mentioned about mosaic palette versus IDEX versus dual nozzle. Which approach are you taking?
Multi-material is going to be.
We don't care so much about colors. We're really into materials, and like being able to do software-defined materials is the ultimate goal. And whether those properties are optical, like color, or mechanical,
like stiffness or
fiber reinforcement. That's all around. We need to be able to mix color, mix materials, and not just color. So ink jetting on color isn't going to cut it for us.
Yeah.
So I suppose rather than talk about our approach, let's talk about our goals. And our goals are to be able to have really effective mixing, so a fully homogeneous melt, as well as being able to do sharp transitions in a responsive fashion.
That is of course the holy grail. So being able to transition rapidly and having full mixing. But yeah, we're not satisfied with the kind of results that we've got in those capacities yet.
I suppose the performance is very good. It's just that there's reliability issues.
Precisely. Yeah.
At the moment, I think the mean time between failure is about like 90 seconds.
No, I don't know. We've had 2 minutes.
No, we've had 2 minutes.
But yeah, there's there are issues, but we're working on those at the moment.
Yep.
It's hard.
Right. So we talked about V6, V7 plans basically.
Yeah.
Yeah. Some people asked about Titan and whether you have anything to share about what's next for that line of products.
I suppose maybe the answer is that may be the same question.
You have something working on?
Yeah.
Okay, but nothing to share yet. This is a nice one. Florian Kuch, I guess he's like Austrian or German or Swiss. A lot of the limitations of FDM printing speed are due to filament melting rate limiting the volumetric speed.
Yeah.
Would you agree with that? And do you have a solution? Well, I guess you have Volcano.
A lot of the time, yeah. So even when you're printing Volcano with a large nozzle, you can see the material comes out and it's not fully molten.
Yeah. And to talk about the kind of history of this, when we were designing V6, printers, tended to print about 30 millimeters a second with maybe 50 millimeters a second infill, and that was kind of your bag a few years ago.
Yeah.
Nowadays that's no longer the case, and so Volcano came out and enables a whole bunch of new things. There's something I'm working on which is a bit of a crazy moonshot project. I don't know if it's going to work, but theoretically it's glorious. I don't know how we're going to manufacture it, but there's something there, and definitely from at TCT the conclusion is that there must be a super volcano. We must do a
something that goes faster. It's basically always melt rate limited though. Is the fundamental answer to the question.
To a certain extent. I mean, it also depends on layer height, right? If you go down far enough. And what I've been seeing with most printers that are belt driven is around 60 or 80 millimeters a second, depending on your accelerations. You are just going to get the degradation from overswing, from ripple.
The term print speed is kind of confusing and conflictory, because of course the speed of the printer is one speed, but the speed or the time that it takes to finish a print is another question. And of course, if you just put a different nozzle number in your slicer, most slicers will say, okay, great, well, I've now got 3 layers at, say, 1.2 millimeters wide. So actually the thickness of the wall, the amount of material that you're extruding is going up, and there's a whole bunch of other things that change, of course. So yeah, just changing the nozzle size and changing it in your slicer actually will mean that your part has probably got more plastic in it and probably takes about the same amount of time because of that fact. So tuning those things and finding a balance where you have basically the same part but printed faster is a bit more intricate than that, and I fundamentally see that as being driven by the speed that you can melt and process plastic at.
Yeah.
Matt O'Gorman Smith is asking or suggesting a EDM profile, star shape profile in the heat block, like. EDM might be a bit overkill, but
you don't have to make it by EDM.
Yeah.
Yes, basically, yes. So you got me. That's basically what's occurring here. It's more complex than that because we're kind of trying to synchronize it with the flow parabola, flow parabola melt, and then track it with the fins down. If you see what I mean. So
You lost me.
As the material at the top, when it's first beginning to soften,
Right.
you want very small.
Oh,
like,
right. So you don't get the
call them.
resistance.
Yeah, exactly.
Yeah.
But as you go down and it becomes more molten, then you want more engagement to
Yeah.
get more heat in.
And get more heat into the center.
Okay, one last question on the pumping as much heat as possible into the filament. Peter Birmingham is asking, why not just have a dual Peter cartridge?
So that's exactly that was the first test that we did. So we've actually I've had 2 or 3 volcanoes.
So
stacked on
that
top
is
of each other.
okay. That is in line. I think that the question is parallel. Like instead of one Peter cartridge, have two.
The conductivity of the aluminium
Yeah.
really is perfectly high enough. I mean, it's astronomical compared to the
And
conductivity
the
of the
amount
material.
of power you can get from the one heater cartridge
plenty.
is
Yeah,
enough.
it's
Plenty.
Okay.
I mean,
Yeah.
40 watts is plenty enough, or 30
I
watts.
think Tim Elmore did the maths once, and even a volcano only consumes like single-digit watts to do the phase change
Yeah.
energy amount of the
Yeah,
plastic.
minus losses, of course, but
The important thing to say about why that idea doesn't work to increase speed is the limit is the thermal conductivity of the plastic.
Yeah.
That's all it is. Like all of the speed constraints are around. You've got your bore, and then it's full of plastic, and you need to get heat from here to here. And if you look at all the thermal resistances in the system, this one is orders of magnitude less conductive and provides more resistance than aluminium, the heater cartridges. That's all a red herring.
All right, nozzle nozzle shapes.
Cat-shaped nozzle orifice.
Yeah. So Nobadan Miyachit, sorry, I'm not going to try to pronounce that. Your opinion on airbrush nozzle adapters, and the pros and cons of a pointy nozzle.
Yeah, okay. So first up, I love all of Renaud Girac's work, and I actually had him get one of the dice machines. I've not used that nozzle adapter, so I can't speak for it, but he's a great guy, and he says it's awesome, so it's probably awesome.
Probably.
Pointy nozzles are really useful at times, especially for these very, very fine prints. They also have their downsides, because necessarily a pointy nozzle has a very long thin path, and so provide more back pressure, because you can't fit in a drill cone in the bottom.
You can't pour all the way through it with the 1.7 or 2 millimeter.
So we're design constrained on the amount of pointiness we can do while still achieving the correct pressure and laminar flow within the nozzle, and that's really important, so we don't want to change that. But a pointy nozzle can provide benefits for cooling, because you get less radiation, because the angle is different, you get less radiation, heat down, and you can get more air flowing over. So for tiny details, I do see the...
And with the smaller nozzle bores, you are actually, decreasing the size of that flat tip.
Well, that's obviously another big factor. So one of the big kind of design, I suppose one of the big numbers that you can change about a V6 nozzle is the size of that tip, and that's something that we spent a lot of time tuning and getting right.
It's not the size of the hole in the tip, that's the size of the flat
that surrounds it.
Yeah.
So that flat actually provides a lot of function while you're printing. So say you're printing between 2 tracks and you want to put some material in here. If you're not covered, then you could end up with the material coming up either side. So being able to iron it down and flatten it as you print is a big advantage, and can drastically improve both the quality of the top surface, but also your bed adhesion on the base.
Yeah. And on the topic of nozzle size, Random Stuff is asking, do bigger nozzle sizes actually give a stronger part in the end?
So Volcano has appreciably stronger parts, and the reason for that isn't necessarily because the nozzle size is bigger, it's because you're putting down more thermal energy as you print. So
you're heating the material more thoroughly.
The material has the same temperature, but it has more heat, so there's more heat in the area.
It stays hotter for longer because the surface area to volume ratio changes, and the volume goes up as a cubic function while the surface area goes up as a square function, and so it's hotter for longer.
So you put one track down on top of another, and the area that's trailing behind the nozzle stays hotter for a longer period of time, so you get better bonding between the layer above and the layer below, because there's more plastic.
It fuses better.
Yeah. So So that's why we see such large improvements for the Volcano, like in terms of mechanical performance.
We should measure that. There's a paper in that.
Definitely, yeah.
Probably, yeah. And also, again, that misconception from Michael Scholz, 2.85mm versus 1.75mm. isn't 3mm better for high throughput?
Well, if you go back to what Sanjay was saying about the thermal conductivity of the material, the logical conclusion is no, because actually the main constraint is to get the heat in.
We thought that, but we were wrong. One of our interns did a study on this that we had done, and because the 3mm filament is in there for longer, it actually heats up a bit better. Now the difference
is...
We've been preaching the wrong thing.
Yeah, I know, right? We've been saying the wrong... But, like, empirical results say that the 3mm is bigger. I'd like to take that to its logical extreme and investigate, what that line looks like, because I bet it's going to not be linear.
I guess it's going to be interesting just to go past what we have right now, the 3mm versus 1.75. Maybe try a 5mm or 10mm rod, and a tiny 1mm.
So we're part of a consortium which includes some of the large printer manufacturers like 3D Platform, and they've done a really responsible and intelligent thing, which is reached out to everyone in the community that has an interest and said, let's make a standard for a larger filament diameter. That standard isn't finalized yet, but we have video conferences, and we're going to make sure that if the filament diameter is 5mm, then it's called 5mm, not 4.85 and 5. None of that nonsense. Please and thank you. Even the marketing guys behind us are laughing.
No, I think they're reading chat. Yeah. Maybe another day.
The what? The shirtless?
Yeah. Where is it? Cinnamon Beard is saying Thomas is the hottest man ever. Please do a shirtless calendar.
I'd buy one. Yeah. We'll all get one. Maybe everyone here can have.
Can you do a shirtless calendar in 3D scanned, and then we can print shirtless Tom in lots of positions?
Ooh, you're giving me ideas there.
Yeah. We'll try and keep it highbrow.
Yeah, we've got to not get this demonetized for Tom.
Alright, I'm getting confused here. 3mm is cheaper, yeah. Dual Titan Arrow. That's been something that's been brought up, like how dual...
So there's a Titan...
No, okay, but well, let's postpone that for a second.
Yeah.
Because there were a few good questions about making the heated zone longer instead of, even longer than the volcano.
Yeah.
So like
Josh, that was what I was.
Double volcano.
This is what we were on about.
So we started with. Yeah.
So we did some playing with basically having a volcano. We had some old V5 heat breaks which were I mean, it was literally just something we did at a weekend. But if you take a volcano and then you put a V5 heat break in it and then you put another volcano below that, I think we maybe did 3 in the end. But with just 2, you end up with a preheating stage, which can be run at a lower temperature than the print temperature.
So you don't degrade the plastic that might be in there for a very long time.
Exactly, and then you have the lower one, which is running at a higher, at your print temperature. Right. And we got obscene results. I mean, you can print
as in good or
obscenely good results. Like you can put a lot of plastic.
Now, there's a reason why that's not practical. Before you will go and do that, and then complain that you've bent all your heat breaks because it creates a really
precision
long.
Or what's the downside there?
That's of course one of the outcomes, but we'd never tested it with small enough nozzles to really ascertain if there was a big precision problem there. So
it looked good enough.
It looked good.
It printed quite nicely.
Yeah,
very nicely
good.
Actually.
It looked good and it printed nicely for large parts. We didn't do thorough enough testing on smaller parts with smaller nozzles.
And doing that creates a massive lever that can and will bend your heat break with only minor print knocks and things. So we need to do a super volcano that is more robust than what is being described there.
Right. Okay. Anything else you guys just want to talk about?
Maybe the Titan Joule affair.
This is amusing. This Twitter post. The water-cooled V6 on a... that's cool.
If you check out the announcement on Twitter, someone y.delzane posted just a water-cooled converted V6. But
Titan mirrored to clarify the situation.
Yeah, so exactly. So obviously there was, in the beginning there was Titan, then we released the Titan, which is basically the same, but the entire thing's been mirrored so that you can get the 2 heads slightly closer, which saves in X or Y space depending on how your printer's set up. Yeah, I don't. Was there anything more? That
No, other than that, just seeing people doing double Titans.
Yeah, that's we've got an Aero one of those available and I think there's also going to be an Aqua one. Too.
Yeah, there should be. There's no reason not to.
But a dual Titan is not something that we've kind of looked into. That our rather pathetic attempt at that was to just mirror it, which does get you a few more millimeters. But what we haven't gone as far as to develop is something which is a Titan which is specifically for dual.
Yeah. I mean, mirrored gives you a lot more design freedom in how you want to arrange your printer,
precisely,
while still allowing you to pack them together. There's no reason to join them into a single product. You're not going to be able to make it smaller because you're basically constrained by the motors.
We might be able to.
Yeah, I suppose.
All right, cool. I guess that is
American or British. I think
American.
British. Yeah, we're British.
Yeah.
Are we in Britain?
We are apparently in Britain.
All right, so yeah, I guess that's a good enough place as any to.
Yeah, I think that's cool.
Watch
out for Tom's video on his walk around. We showed him some really, really cool stuff. So, yeah, new products coming up in that. Really cool, like fun new products.
Cool. Happy days. All right. Well, thanks everyone for watching and tuning in.
Yeah.
No, it's a bit antisocial for the guys on the west coast of the States.
Yeah, but you have the recording. You had the chance. Well, when did we announce this? I think they were all asleep.
Yeah. Oh well. Nice.
But I
They'll be
hope,
a pleasant surprise when they awake.
Yeah, I hope it answered most of the questions you guys had. I mean, we did talk about clones, water cooling, the ultimate hot end, putting wild stuff together.
Yeah.
Good fun. Well, thanks for your time, guys.
Thank you very much.
Thank
Cheers,
you.
Tom.
Yeah. See you in the next one.
Bye.